Yeah, in continuation to the previous class, we have seen in the plane different forms to the equation of the plane. We are working out the problems on that one. Let us continue working out the problems. Let me share the screen. And I think we stopped at example 43. Let us see that. This is example 43. Pranit, do you hear me?
Yes, sir, I hear you.
So here we have seen in the previous class the set of planes based problem, example 43, set of planes. Now this one is example 44. If you see the vector equation of the plane passing through the horizon and the line of intersection of the plane r dot a is equal to lambda, r dot b is equal to mu is passing through the horizon and the line of intersection of the plane. So what are the vectors given there? What are the planes given there? R bar dot A bar is equal to lambda. And second plane is R bar dot B bar is equal to mu. And passes through 0, 0. Let us see that. We have seen this yesterday itself, the set of planes concept. The concept of set of planes. That is, if you see the set of planes the planes, you can say in this way, this is one plane and this is another plane. Now the required plane is passing through the line of intersection of these two. The required plane is passing through the line of intersection of these two. That is, this is one of the planes. Like the pages in a notebook, you can understand that. Pages in a notebook, if you open, you will understand the set of planes concept. If you take the first plane as P1 equal to 0, second plane as P2 equal to 0, then the equation to the set of planes is given by P1 plus lambda P2 equal to 0. Now it is also given that it passes through 0, 0, 0. The required plane is passing through 0, 0, 0. Okay. Now, how to get it? How to get it, please? You might have remembering yesterday itself, we worked out the problem based on this set of planes concept. Set of planes concept. So, family of planes or set of planes is given by P1 means this is R dot A. R bar dot A bar minus lambda plus some K into R bar dot B bar minus B is equal to 0. Okay. But it passes through 0, 0. It passes through 0, 0. It passes through 0, 0 means replace R bar with 0, 0. Implies 0 minus lambda plus k into 0 minus mu is equal to 0. Okay, which implies that k is equal to lambda by mu. Substitute this lambda, this k value in this one now. Therefore, required plane is, substitute k here, R bar dot A bar minus lambda, k value lambda by mu into R bar dot B bar minus mu is equal to 0. Just see that please. K replaced here, and you will get this lambda getting cancelled. These two are getting cancelled. Therefore, this required plane, you will get it as R bar dot A bar plus lambda by mu into R bar dot B bar is equal to 0. This is what the answer, because it passes through origin here, constant gets cancelled. This should be your answer. Praneeth?
Okay, sir.
So if you see this, this one you can see now. Let me show you the options and you understand it.
Yes, sir.
Let's say this R bar taken common, lambda by mu means you will get this one.
Yes, sir. Option. Yes, sir.
It is in the white color. Let me show you that. This one is the answer. And if you cross multiply now, you take R bar common, you are getting mu A bar plus lambda B bar. Mu A bar plus lambda B bar. Let us see that mu A bar plus lambda B bar. Which one is the answer? Mu A bar plus lambda B bar. This one. Mu.
Option C, sir.
Option D, no?
D.
Option D is the answer. Okay. So this is again using the set of planes only. Understand that? Again using set of planes only. What is that we did? We did the same as previous, but here only the difference is the vectorial form is directly used. R dot A minus lambda plus k into R dot B minus mu is equal to 0, but it passes through 0, 0. And hence what we did, we have simply substituted 0, 0, 0 in place of R bar. And thereby we have got that simplified as k is equal to lambda by mu, and that lambda by mu obviously is substituted in place of k, and thereby we have got the required plane. Now this one, please. Example 44, we did it. Now let us move on to the next part of it. The equation angle between the planes. This is very simple, Praneeth, and I hope you can say that easily. X plus 2y plus 2z is equal to 3.
Minus 5x plus 3y plus 4z is equal to 9.
Minus 5x plus 3y plus 4z is equal to 9.
Okay, sir.
So if you want the angle, no, angle direct formula cos theta.
Yes, sir. I remember the formula.
A bar dot B bar by mod A bar mod.
Not B bar. Yes, sir.
Total form, it is easy.
Yes,
So
sir.
A bar dot B bar means 1 into -5, -5.
-5.
2 into 3, 6.
6.
Plus 2 into 4, 8.
8. By
Divided
root 9.
by, that is, you're right.
1 plus 4 plus 4. 1 plus 4 plus 4. 25 plus 9 plus 12.
That's good. So this is 7,
7. No, sir. Yeah, sir. 7.
25 plus 9, 34 plus 16, 34 plus 49.
49, sir. Root 7.
49 under root means 7.
7.
So your cos theta is 14 minus 5, 9 by 21. 9 by 21 means 3 by 7.
3 by 7.
So cos inverse 3 by 7. But you got the different answer here. Something wrong here. Let us check it out. It is 9. 25 plus 9, 34. 34 plus 16.
50, sir. 50.
Oh, that is wrong here. 50. So root 50.
5 root 3.
You're right. 5 root 2.
Sorry, 2.
5 root. So 3 getting cancelled. You'll get 3 by 5 root. Three root 2 by 5. 3 root 2 by 10. He rationalized it. If you multiply with root 2 and divide it root 2, this root 2 into root 2, 2, 5 into 2, 10. So you get 3 root 2 by 10. Okay. Similarly, distance between the planes, distance between the two parallel planes. Pranit, how to compare this with the 2D line? 2D line formula and 3D plane formula are one and the same. What I've been telling you, if it is something like two lines, cos theta is equal to so angle between two lines, cos theta is a1 a2 plus b1 b2 by root over a1 square plus b1 square into a2 square plus b2 square. If it is a plane, no extra thing what you get. This is only thing to be noticed. The difference between
C1, C2, yes, sir. There will be an extra alphabet.
So this is the angle between two lines and planes, the transformed form. Okay. Similarly, if you take the distance between two parallel lines is C2 minus C1 by root over A square
A1
plus
B square. Yes, sir.
and if it is a distance between the planes, it is modulus of D2 minus D1 by root over. You'll get an extra term here, A square plus B square plus C square. Kaushik. Now raising the hand and motivating. Right. So this is the comparison between 2D line, parallel lines and parallel 3D planes.
Okay, sir.
So if you are thorough, good evening, Kaushik. So this is the comparison between 2D line concepts and 3D plane. Okay, now the distance between the planes here. What is that you have to observe particularly? Whenever two planes are given in this form, 2x, I'm talking about this 46 problem. 2x plus y plus 2z is equal to 28 and 4x plus 2y plus 4z plus 5 is equal to 0. Don't forget and never forget. The formula can be applied only when the coefficients are equal. This must be equal. Otherwise, you cannot apply the formula. And how do you understand that they are parallel? If you take the ratio 2 by 4 is equal to 1 by 2 is equal to 2 by 4 is equal to 1 by 2. So what happens when you take the parallel planes, before applying the formula itself, you have to make the coefficients the same. That is why multiply with 2. The first plane multiply with 2. 4x plus 2y plus 4z minus 16 is equal to 0. And this one is 4x plus 2y plus 4z plus 5 is equal to 0. That's it. Therefore, distance between them, you can straight away write the formula modulus of d2 minus d1 upon root over a square plus b square plus c.
Yes, sir.
So d2 minus d1 means it is minus 16 minus 5, 21 divided by root over 16 plus 4 plus 16. 32 plus 4, root 36. You'll get. So it is 6. 21 by 6 means 7 by 2 is the distance between the parallel planes. So what is a twist that is to be observed, particularly in the objectives? You may be knowing the formula, but you should never forget, the coefficients must be made equal.
Yes, sir.
Here the coefficients, unless the coefficients are made equal, you cannot apply the formula directly. Either you have to multiply this with 2 or you have to divide this with 2. Whatever you do, both are same.
Okay, sir.
To make it equal. So in this case, what I did, I multiplied the first plane with 2 and I made the coefficients equal. Then I applied the formula. Let us move to the next problem. Example 47. A tetrahedron has vertices OABC given. Then the angle between the faces OAB and ABC will be. This is also an important model, and where generally the students get confused in finding the angle. Not only that, the tetrahedron, of course, you must have clear idea about the tetrahedron. Let me draw this. This is simple. Like I'll take the base plane of the tetrahedron as ABC. This is, let me say this as A, B, C. Let me take another point not lying on. Let me take another point not lying on the plane of ABC. Let me take it as some O here. Let me take it here, or otherwise you can take it here also, no problem. O. Then what happens? You can see this is O. These 3 points of on the base are to be added. This is the tetrahedron. Let me show it now. Let me show it. This is what the tetrahedron is. For this tetrahedron, these are the coordinates given. O is given to be 0, 0, 0. O is 0, 0, 0. And let me write A here. A is, this is A, please, 1 to 1.
Yes, sir. 1 to 1.
B, 2, 1, 3. This problem, example.
Minus 1, 1, 2.
Minus 1, 1, 2. Okay.
Yes, sir.
Now, this is What is the question here? The angle between the faces OAB and ABC. OAB and ABC, please. Okay.
Okay,
So OAB, the plane onto your face, and OBC.
Start.
Now you have to find out the angle between the planes OAB and ABC. OAB and ABC. So let us understand. OAB and ABC, you have to understand that angle between planes means angle between the normals. Angle between planes means angle between the normals. If you take the normal, to the plane OAB, for example, plane ABC, let me take first. Plane ABC, let me take. This is the normal, let me say. And OAB normal is like this. Okay. Now this is to be find out. This is the normal to ABC. And this is normal to AOB. AOB means I will mark it here. Just a moment. I'll mark it here. AOB. Okay, so the angle between these normals is angle between the planes. You have to understand that. AOB and ABC, the angle between these two is angle between the normals. So how to find out the DRs of the normal here? OAB DRs, please. OAB DRs. Or not OAB DRs, the DRs of normal to OAB. DRs of normal to plane OA. Simply you have to find out OA bar cross OB bar, please. You have to find out the cross product of OA and OB. So what is OA bar cross OB bar? Let us write. Is equal to whatever is needed. That's what I'm writing. Whatever needed means I need only the OA. OA means 1 to 1. OB means 213. So DRs is now 6 minus 1, 5. I'm writing directly. If you do not understand, ask me, please. And 2 minus 3 minus 1.
Understood.
And it is 1 minus 4 minus 3. This is DRs of normal. Next, DRs of normal to plane ABC. Do you tell me, any one of you, please? Even though your mic is not active, you can type it. How to find out the DRs of normal to plane ABC? Kaushik, what is we find out? This is plane ABC, the base plane. How to find out the DRs of normal to plane ABC? AB bar cross AC bar is equal to, what is AB bar, please? OB minus OA. OB minus OA. Renate, 2 minus 1, 1. And OB bar minus OA bar.
2 minus 0. 2 minus 2 plus 1.
This is 2 minus 1, OB minus OA.
Okay.
1 minus 2.
Minus 2.
Minus 1.
And 3 minus 1.
Minus 1, 2.
2.
AC bar, similarly, AC bar, please. AC bar. OC minus OA. Minus 1, minus 1, minus 2. 1 minus 2, minus 1, 2.
Minus 1.
1.
Yes, sir.
Now it is minus 1 plus 2, 1. And it is minus 4 minus 1, minus 5. And it is minus 2 minus 1 minus 2 minus 3. Therefore, required angle, please. This is what the required angle now. Angle between OAB and ABC is equal to cos inverse of dot product, please. Dot product. 5 into 1, 5 plus 5, 10. 10 plus 9, 19. Divided by root over 25 plus root 35. And it is also root 35. So your answer for this is now cos inverse of 19 by root 35, cos inverse of 19 by 35. So what is that to be understood here, please? Important model, please. Important model, what I'm saying. Important model, what I'm saying. If the angle between two planes is to be find out, the angle between two planes is to be find out, the angle between two planes is equal to angle between their normals.
Okay.
So to find out the angle between two planes, you must know the DRs of the normal to the plane. But here indirectly given, normal DRs are not given here, but all the vertices of the tetrahedron given. If I want to find out the DRs of the plane, DRs of the normal to the plane OAB, DRs of the normal to the plane OAB, then what is to be done? I have to write OA bar cross OB bar. That's what I did. OA bar cross OB bar. Simply, if you find out the determinant, then you will get 5 minus 1 minus 3. Similarly, DRs of the normal to the plane ABC, the base plane in the red color, you can see. The base plane in the red color is nothing but AB bar cross AC bar. AB bar cross AC bar, if you see, AB bar is OB minus OA and AC bar is OC minus OA. I wrote that and I got it. This was cross product or DRs of the normal to the plane of ABC. You know DRs of the normal to this plane and you know DRs of the normal to this plane. And the angle between the planes is nothing but cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. If you apply that, it is cos inverse 19 by 35. I hope you understand that. Both of you, please respond. This is an important model.
Yes, sir. Understood it.
Let us check the options. So your answer must be cos inverse 19 by 35. Let us check the answer. This one, first option. You can see the first option. First of all, understanding the question becomes difficult in this model. Angle between the planes, you must know the concepts here. Angle between two planes is equal to angle between the normals. And after that, what is that you have to understand how to get the equation, how to get the DRs of the normal by getting the cross product. By getting the cross product of two lines on the plane, you will get the DRs of the normal. It's an important model. Let us go through the next question. the distance of the point 2, 1, minus 1 from the plane. Can you try this? I'll write the data. This is straight question, please. What is the point 2, 1, minus 1? Is the point. Now the plane is this. Now the plane is this. And we need the perpendicular distance from that point to the plane. This is the perpendicular. You have to find out the perpendicular distance from that point to the plane. Let me write the equation of the plane also. Let me write the equation of the plane x minus 2y plus 4z. Is equal to 9. Now, Kaushik, I need your mic to be repaired very, very urgently, please. Without interaction, I cannot teach. Yesterday it was happened, and today also it is happening, and you should not neglect it. I need the interaction. Somehow or other, you have to get it repaired. So we need the perpendicular distance from the point to the plane. Let me compare it with the perpendicular distance of a point to a line. Let me take the point as x1, y1. And let me take the line. I'm revising, I'm comparing 2D line with the 3D plane. If you want the perpendicular distance from this point to this line, the perpendicular distance is simply got by, do you remember, Praneeth?
Yes, sir. I
Perpendicular
remember.
distance formula, modulus of ax1 plus by1 plus c divided by root over a square plus
B square.
b square. Why I wrote this, you can understand.
Okay.
What is that will be added in this case? You tell me, please. Now you tell me the formula.
ax1 plus by1 plus cz1 plus d by under root a square plus b square plus c square.
That's good. That's good. Now let us apply this. This is modulus of, let me write that directly. 2 minus 2 getting cancelled, minus 4 minus 9. Minus 4 minus 9 whole divided by, come on, tell me, root over
2 square 4
a square plus b square plus c square. That means 1
square
plus 2 square plus 4
square. It is equal to my
13, no? 13. Minus 9 minus 4 minus 13.
Sir, minus 13 by under root 17.
Under root 16 plus 4, 21, no? Under root 21.
Sorry, 21. 21? Yeah, 21.
Under root 21, please. That is the answer. Strike question, please.
Yes, sir.
And if you learn them through 2D formulae, both will be revised simultaneously. Plane and the 2D line.
Okay.
3D plane and 2D line both will be revised. The only thing is Z extra there.
Okay.
That's it. So that is a straight question. That is why I'm not taking more on that one. Now, unit vector perpendicular. This is very important, please. This I already discussed. The unit vector perpendicular to the plane. Just now we applied this also. Unit vector perpendicular to the plane determined by the points. What are the points given? P 1 minus 1 2 and Q 2 0 minus 1 and R, let me say 0 2 1. Now what he needs is, he needs a unit vector perpendicular to the plane containing these 3 points. That unit vector perpendicular to this plane will be like this, let me say, like this. This is the perpendicular. You have to understand. Just see that. Both of you, we did the problems so far based on this. Now, let me understand. Do you tell me this or not? Now, what I need is that yellow line I need. That yellow line is nothing but the normal to the plane of PQR. How to find out the DRs of that normal? Please respond. Yes, please. Yes, please. Respond.
Sir,
PQ bar cross QR bar. That's it.
okay, sir.
Find out PQ bar cross PR bar. What is PQ bar? What is PQ bar? He replied that as cross product. Let me write whatever we need. That's what we write. That's it. PQ bar is needed. OQ minus OP.
OP.
That is 2 minus 1. 1,
1
0 plus 1. 1 minus 1 minus 2
minus 3.
3. That's good. And PR bar. OR minus OP.
So,
That is 0 minus
0
1 minus 1. 2
and
minus 2 minus 1. 3. 1 minus 2.
1. Sir, is it 1? Oh, yeah, minus.
Minus 1 plus 9, 8. And it is 3 plus 1, 4.
4. And
it is 3 plus 1, 4.
4.
These are the DRs of the normal to the plane.
Yes,
844. 844, please. Okay. That's what it is. Let us check the answer. But he needs a unit vector. Just don't forget, he needs a unit vector. How to get the unit vector now? You have to divide with its modulus. Therefore, unit vector is equal to (8i) plus 4j plus 4k divided by root over 8 square plus 4 square plus 4 square. Plus or minus. Why plus or minus? 1 above and 1 more below. This is downward direction negative, upward direction positive. Then what happens? It is 64 plus 32, please. How much is it? Just tell me, please. 64 plus 32. 96, huh? Root 96. Then it will be plus or minus. Take 4 common. 2i plus j plus k. And the denominator is root 96, please. Root 96 is 4 root 6. So your answer is plus or minus 1 by root 6 into 2i plus j plus k. That's it. That is the answer. So how to get the unit vector? A cap is nothing but A bar by mod A bar, always. These are nothing but in three-dimensional geometry, we call them as DCs. In the vector form, it is A bar by mod A bar, A cap or A cap. And in the 3D form, it is simply, you have to understand, they are nothing but DCs. Unit vector is DCs. Clear? Let us check the answer. Which one is the answer here? Plus or minus he has not given, but 2a minus j plus k by root 6. I think that should be the answer. Let me check. 2i plus j plus k means which answer, please? 2i plus j plus k. The second option.
Second option, sir.
B. B is the right answer. B is the right answer here. But if we put plus or minus, this is to be taken. If in the advanced examination, if it is to be given for in more than one correct answer type questions, plus will be given in one option, minus will be given in another option. Then you have to choose both the options. Both are correct. One is above, one is below. That's what I have shown even in the diagram also. Like what? This is one above, one below. One is plus, upper one is plus, and below one is minus, or vice versa, whatever. The next one is 49. We finished it just now. Let us go for the 50th one. The perpendicular distance from origin to the plane to the from origin to the plane through the point 2, 3, minus 1 and perpendicular to a vector. The plane equation is indirectly given now. Plane equation is not directly given. So what is to be find out? You have to find out the perpendicular distance from 0, 0, 0 origin to a plane. To a plane. That plane is equation is not directly given, indirectly given. But it is given that it passes through a particular point. 2, 3, minus 1. And perpendicular to the vector given. Understand, please. And perpendicular to the vector. This plane is perpendicular to a particular vector. Let me say this is the perpendicular vector. Let me say. What are the, which vector it is? 3, minus 4, 7. Of course, it is not a point. I'm writing DRs. I'm not keeping them in brackets. This is what the data given. This is what the data given. And what is to be find out? What is to be find out? You have to find out the perpendicular distance from the origin to the plane. Perpendicular distance from the origin to the plane. This is the distance to be find out. Okay. Praneeth and Kaushik, is it clear, please?
Clear, sir.
But we need the equation of the plane, then only you can write the perpendicular distance. How to get the equation of the plane? Equation of the plane is simply got by this formula. Whenever it is passing through a point and normal DRs are given, the equation of the plane is given by A of x minus x1 plus B of y minus y1 plus C of z minus z1 is equal to 0. I hope you remember this. This is
Yes, sir, I'll remember this. Yes, sir.
So ABC are given to be
4, 7, 2.
ABC are nothing but 3 minus 4.
4, 7.
Come on, tell me x1, please. Minus 2.
Minus 2.
minus 4 to y plus 4. What is C? 7. What is Z1? Minus of minus 1 equal to 0. Implies 3x minus 4y plus 7z minus 6 minus 16 minus 22 minus 22 plus 7, please, minus 15 equal to 0. Therefore, perpendicular distance from the origin, please. Perpendicular distance from the origin. I need not tell you that it is a straight formula. What is that straight formula here? Mod z by root over a square plus b square plus c square. If it is in the 2D form, mod z by root over a square plus b square. If it is in the 3D form, 3D means plane. Modulus of d divided by root over a square plus b square plus c square. Please apply and tell me the answer, please, both of you. Please apply. This is ax plus by plus cz plus d equal to 0.
Yes, sir. I'll do it.
This is the origin. And please do that. And tell me the final answer, Kaushik and Praneeth.
Sir, it's mod 15 by root 74.
That's good. Mod d means modulus of minus 15 by root over a square plus b square plus c square. 9 plus
9 plus 16 plus
25,
49.
25 plus 49, no?
Yes, sir. 49, 74.
Very good. That's what it is, please. So here, this formula is easy to apply, mod d by root over a square plus b square plus c square. But the plane equation is not directly given. Plane is passing through a point and its normal drs are given. So we made use of the formula a of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. We substituted every value in this one. We got the equation of the plane. And after getting the equation of the plane, it is modulus of c by root over a square plus b square plus c square. That's it, please. So answer is 15 by root 74. Let us check the answer. But here it is given to be 13, I think. We got 15. That means there is a simplification mistake. Let me check once. This is minus 6 plus 16 minus 22. Plus 7 is minus 15 only we have got here. That means entering the data may be wrong. X minus 2 minus 4 into y. This is we wrote wrong. This is y minus 3. Please. This is y minus 3 because this is the point. And z plus 1 is correct. Now this is 12 plus 7, 19 minus 6. 19 minus 6, please. 13. 13, please. So this is not 15, 13. That's a simplification mistake. This is 13. And thereby your answer must be what, Pranit? Your answer must be modulus of
15 by root 74.
correct. Modulus of 13. Yeah. This
Okay,
is
sorry, yeah, 13, sir.
15 we wrote wrong.
Yes, sir,
It is
13.
correct. 13 by root 74.
74.
Okay, Kaushik, are you listening to me?
Yes, sir. Yes.
So that's what it is. Projection of PQ on the plane. Next. PQ are given. P is 0, 1, 0. Q is 0, 0, 1.
Yes, sir.
And the plane is given to be x plus y plus z is equal to 3. You have to find out the projection. Projection we already did in the vectors. This is the plane given. Let me say x plus y plus z is equal to 3. And 2 points are given that are not lying on the plane, let me say. One is P0, 1, 0. And another point Q 0, 0, 1. Now you have to find out the orthogonal projection. You have to find out the orthogonal projection of the line on the plane. Orthogonal projection of the line on the plane. Let me do that. Just a moment. What is the meaning of orthogonal projection here? These are the 2 points here whose orthogonal projection is needed. Let me make it a little more slant so that you'll better understand it. Just a moment. Let me mark Q here. And we need orthogonal projection of PQ. Orthogonal projection of PQ. This is a line PQ. Orthogonal projection means you have to drop the perpendiculars from P onto this plane. This is one perpendicular. This is another perpendicular. What we need is this yellow line we need. So this is, let me say, P dash, Q dash. After finding P dash and Q dash, you have to find out the distance between them. This is only the way to do it. This is perpendicular. This is perpendicular. That means you have to find out the foot of the perpendicular here and here also foot of the perpendicular onto the plane. Foot of the perpendicular, I'd like to revise the formula, which is very much there in 2D line also. H minus x1 by A is equal to K minus y1 by B is equal to, here in this case, some L minus z1 by C is equal to, foot means you will get only minus of. If it is image, you will get 2 extra, minus 2 extra, 2 extra here. Minus of ax1 plus by1 plus cz1 plus d divided by root over, root will not be there, a square plus b square plus c. This is foot formula. Now I'll make it simple for you by giving you the short form of it. I'll make it simple for you by giving the short form. What is the short form to find out the foot? Just listen to this, please. Foot is equal to, come on, cross multiply this, x1 minus a lambda, y1 minus b lambda. Z1 minus C lambda, where lambda is equal to A x1 plus B y1 plus C z1 plus D by A square plus B square plus C. See it carefully, please. Now I need P dash here, P dash. Let me find out lambda first. Lambda for P dash is, in this case, simply substitute the point in the plane equation. Substitute the point in the plane equation. See, then if you substitute the point in the plane equation, what is that you get in this case? In this case, follow this carefully, please. In this case, your lambda for the short form is simply 0 plus 1 plus 0, 1. 1 minus 3 minus 2.
Minus 2.
Divided by 1 square plus 1 square plus 1 square, 3.
3.
Similarly, in this case, your lambda, same, substitute 0 plus 0 plus 1. 1 minus 2. 1 minus 3 minus 2. It is also minus 2 by 3. In both the cases, it is same. Now I need P dash, please. P dash. Same formula. X1 minus A lambda. What is X1? 0. I'm writing that, please. You'll understand easily. 0 minus A lambda. A means 1 here. 1 into minus 2 by 3. Comma. Y1 means 1. Minus B means 1. Lambda means minus 2 by 3. And Z1 means 0 minus 1 into minus 2 by 3. So what is that you get in this case now? It is 2 by 3, comma, 1 plus 2 by 3, 5 by 3, comma, 2 by 3. Okay? This is what you have to understand about P dash. This is P dash. You can do the same for Q dash also. Q dash, please. Can you try it? Both of you, please make it fast. In the similar manner, what happens now? Here you got 0, 1, 0. Here you'll get 0, 0, 1. Here you'll get 0. Here also you'll get 0. But here you'll get 1. That means, similarly, Q dash is equal to, replace here, 0. That means you'll get the same 2 by 3. And here 0, 0, 0 means 2 by 3 again. But 1 here, that means this value, 5 by 3. Now distance between these two, please. P dash Q dash is equal to 2 by 3 minus 2 by 3, 0. 2 by 3 minus 5 by 3, 3 by 3, 1. 1 plus 1, root 2, you will get. Just check it out, please. 5 by 3 minus 2 by 3, 3 by 3, 3 by 3 whole square, 1 square, 1. 2 minus 5 by 3, 3 by 3, 1 square, 1. So P dash Q dash distance is root 2. So its orthogonal projection is nothing but root 2, please. Its orthogonal projection is nothing but root 2. So this length we have got it to be root 2 now. This is becoming a little lengthy, but here foot of the perpendicular is also revised. Foot of the perpendicular is also revised. So this is P, this is the plane equation. We have got two foots here, P dash and Q dash. So your answer must be root 2. Let me check once. Is there any elegant method what he did? Let us check it out. One moment, please. The answer is root 2 only. C root 2, that's correct only. But what he did, PMQ and perpendicular given PQ are perpendicular. Mod MP he got. Mod MP means what? He got the perpendicular distance. Okay, he got this perpendicular distance. That's good. Mod NQ, he got the perpendicular distance here. Very good. And PQ means this is the distance. Okay. Now after that, what he did, mod RP. Mod RP is equal to mod MP minus mod MR. Okay. You got it to be 0. R and P are the same points. So mod NM is equal to mod QR is equal to root over PQ square minus PR square. Okay. He did it in a different way. That's good. What he did is he got the perpendicular distance here.
Distance, sir.
That is simple only. This is good. This method is good.
Easy and simple.
This is perpendicular distance. This is another perpendicular distance. After getting this, we need this distance here. If you need this distance, if you subtract the total distance from Rm, then what he got is he got it to be 0. 0 means P and R are coinciding. P and R are coinciding. That is why it is equal. If you see now carefully, what is the distance between these two? Root over 0 plus 0, root over 0 plus 1 plus 1. Root 2 only distance between these two. PQ distance is root 2, and whatever the answer we got is also root 2. That means this line is very much parallel to the plane. This P and R coincide. P and R coincide. Okay, this method is good. Just follow this. He got simply the perpendicular distances. Okay, now let me see the next problem. Let us close with this problem. This is I'll go for verification for this problem. Just say this cross verification. How to do that? This is a reflection of the point 2 minus 1 3 in the plane. What I am trying to explain you here, just follow this carefully. If you take any plane, this is plane. Now this is the point P. We need its image or reflection. Let me say symbolically R. If you need its reflection in the plane, always understand this is perpendicular, please. This is 90 degrees. Okay, so let me write the point P here. P is 2 minus 1 3. And the drs of the normal to the plane is nothing but 3 minus 2 minus 1. This is a normal, and its drs are 3 minus 2 minus 1. Now, this R is in the options. R is in the options. So, if they are proportional, you can say that is the answer. For example, 26 by 7. Let me write like this. This I am taking up. This one I am taking up. So write the DRs of PR, please. Write the DRs of PR. Let me check. 26 by 7. Cross verification, please. 26 by 7 minus 2 whole divided by 3 is equal to 15 by 7 plus 1 whole divided by minus 2 is equal to this one 17 by 7 minus 3 whole divided by 3 minus 2 minus 1. If these three are equal, you can say this is the answer. Let me check. This is 26 minus 14. 12 by 3, 4. 12 by 3, 4. Okay. That's good. And coming to this 22 by minus 2. No, it is not equal, minus 2. So that is a wrong one. A is not correct. A is not correct. Let us check for B now. Let us check for B. Do you tell me? Praneeth or Kaushik, do you tell me how to check this? 26 by 7 minus 2.
Yes.
26 by 7 minus 2 by 3. Just now we have got it to be 26 minus 14. That is 12 by 3.
12 by 12.
4. Let us check for this. Minus 15 by 7 plus 1. So minus 15 plus 7. It's not equal because minus 15 plus 7. Oh, okay. Minus 15 plus 7 means 8.
Yes, sir, 8.
And we missed it for 7 here, I think. 4 by 7 is there. 7 we are missing. So minus 15 plus 7 minus 8 by 7 by minus 2. So 4 by 7. It is correct. Similarly, this one 17 by 7 minus 3. 17 minus 21 minus 4 by 7 into minus 1. Minus 7 equal. So therefore, B is the option, please. Like that, you can go for reflection. If you want to link up this with the 2D line reflection, how it goes, you know that. Let me revise it. You know that H minus X1 by A is equal to K minus Y1 by B is equal to, it is 2D line now, it ends here and you will get some constant here. But if it is 3D plane, L minus Z1 by C is equal to minus twice of AX1 plus BY1 plus CZ1 plus D divided by A square plus B square plus C square. This is what the formula to be used to get it directly. I hope you understand what I'm saying. Praneeth and Kaushik.
Yes, sir, understood it, sir.
This one is
X1.
X1, correct. This one is X1. This one is
Y1.
Y1. This one is Z1. What is
X minus 2 by A.
This is A. This is B. This is C.
Yes, sir.
And that is the equation of the plane. You can substitute directly.
Clear, sir.
And from this one, you will get HKL values. HKL values gives you the reflection. This is the formula method. And there's a cross verification method. Both can be applied.
Okay, sir.